A 10-kilogram tortoise sits on a seesaw 1 meter from the fulcrum. Where must a 2-kilogram hare sit in order to maintain static equilibrium? And what is the force on the fulcrum? Well, first off, we're going to assume it's a massless seesaw. It doesn't tell us anything about the mass, so let's just assume the mass of the seesaw doesn't come into play. Let's draw what we have here. We've got a seesaw. We've got a fulcrum. Over here on one side, we've got a 10-kilogram tortoise. So its weight, the force on it, is 10g. And that's 1 meter from the fulcrum. 1 meter. On the other side, we have our hare. 2 kilograms, so its force is 2g. And it's some unknown distance from our fulcrum. If it's in static equilibrium, though, we know that the net torque must equal 0. So looking at our torques, the 10g over here, that force times the distance 1 meter, 10g times 1. Now the negative direction minus 2g times whatever that distance happens to be from the fulcrum x must equal 0. So 10g minus 2gx equals 0. 10g equals 2gx, or x equals 10g over 2g, which must be 5 meters. The hare must sit 5 meters from the fulcrum. What is the force on the fulcrum? Well, to find the force on the fulcrum, all we have to do now is look at all of the different forces that we have here. Newton's second law says that we must have some force from the fulcrum pointing back up. So if we write Newton's second law for that object, F net in the y direction, we have Fp minus 10g minus 2g equals 0. Therefore, the force of that pivot point, the fulcrum, must be 12g, or 120 newtons. Hopefully that gets you a good start on torque. Thanks for watching Educator.com. Looking forward to seeing you next time. Make it a great day.